Today we are going to learn about the scalar product of two vectors. Okay, so what is scalar product? When you multiply two vectors and the resultant is the scalar. So can you give me an example of when you multiply two vectors, the resultant quantity is a scalar quantity? So force is a vector quantity, displacement is a vector quantity, and force times displacement gives you what? It gives you work. So work is what? Scalar or vector? It's a scalar quantity, right? Okay, energy is scalar quantity, work is a scalar quantity. Okay, so let's talk about the scalar product of two vectors. So let's suppose we have this block resting on a floor, resting on this floor, and you exert some force on it. So you exert this force which is in this direction. Okay, so let's call it F bar, and because of this force this block gets displaced. Okay, so let's suppose it moves from here to here, so displacement is s. Okay, this much is the displacement. Okay, so now I can resolve this force along two components, one in horizontal direction and one in vertical direction. Okay, so if this angle is theta, okay, this is the angle between displacement is towards right and force is in this direction. So this component is f cos theta, the horizontal component is f cos theta, and the vertical component is f sin theta. Now can you tell me, out of these two components of force, which one is doing the work? The horizontal component or the vertical component? Which one is doing the work? Horizontal component is doing the work. So now I want to write down the equation for work done. Okay, work done by this force F bar in displacing this block, displacing the block, okay, by displacement S bar, which is along in horizontal direction. Okay, so which is in horizontal direction. So I can say that work done is equal to work done by this component plus work done by this component. So I can say it is Fx multiplied by displacement in x direction, Sx, plus Fy multiplied by displacement in y direction. So displacement in y direction is equal to 0. Okay, so displacement is only in x direction. Displacement in y direction is 0, and therefore you can write work done as, what is component of force in x direction? It is F multiplied by cos of theta. Okay, so F cos theta multiplied by the displacement in x direction is S. So you get this equation for work, F multiplied by S multiplied by cos of theta. And if you see here, theta is the angle between the force and displacement. Okay, so product of F bar and S bar, which is work, is a scalar quantity. So we can define scalar product of two vectors like this. So what definition do you get? So magnitude of first vector, which is force, multiplied by magnitude of second vector, which is S, multiplied by cos of the angle between two vectors. Multiplied by what? Cos of the angle between two vectors. Okay, so you are multiplying. Let's suppose you multiply any two vectors, A bar and B bar. So scalar product is denoted by this letter, dot. Okay, so let's suppose C is a scalar quantity that you get when you multiply A bar and B bar. Okay, so the scalar product is represented by dot, and it is also known as dot product. So this is equal to what? Magnitude of first vector A multiplied by magnitude of second vector multiplied by cos of the angle between two vectors. This is the definition of scalar product, and it is motivated by this relation. Okay, so when you multiply force and displacement, you get work, which is a scalar quantity. So you got this. Now we can represent two vectors like this. Okay, so a bar can be represented as ax times I cap plus ay times j cap plus az times k cap, and b bar can be written as bx times I cap plus by times j cap plus bz times k cap. Okay, and now I want to multiply a bar and b bar, right? So c is equal to what? A bar dot b bar, a bar dot b bar, and a bar is ax into I cap plus ay times j cap plus az times k cap. B bar is bx times I cap plus by times j cap plus bz times k cap. Okay, and now this can be written as, so I can multiply this first vector, which is ax times I cap, with this bracket, plus I can multiply this thing with the bracket, plus I can multiply this thing, okay, third vector with the bracket, or third component you can say. Okay, so what do you get? Ax into I cap dot with, okay, it's dot product with bx times I cap plus by times j cap plus bz times k cap. Similarly, plus you have ay times j cap dot with what? The same thing, bx into I cap plus by times j cap plus bz times k cap, and you have az multiplied by k cap dot product with the same bracket. Okay, so now here comes the concept of dot product of unit vectors. Okay, so if I take dot product of I with I, what will I get? So if I take this dot product, how much is magnitude of I unit vector? 1. So it is 1 multiplied by 1 multiplied by cos of the angle between them. How much is the angle? Angle is 0. And how much is cos 0? Cos 0 is 1. So I dot I, okay, I cap dot I cap is equal to 1. Similarly, I can say j cap dot j cap is also equal to, okay, j cap dot j cap is also equal to 1. K cap dot k cap is also equal to 1. Alright, then I will multiply I cap with j cap. So now what will be the result? So it is 1, right? 1 into 1, okay, I cap dot j cap is 1 into 1 multiplied by cos of 90, and cos of 90 is 0, and that's why this is equal to 0. Similarly, you can say j cap dot k cap is equal to k cap dot I cap, and this is equal to 0. Okay, so from here, what can you say? If two vectors are perpendicular to each other, what is their dot product or scalar product? It is 0. Okay, if two vectors are perpendicular to each other, their scalar product is equal to 0. Okay, and now we can easily evaluate this bracket. So when I multiply ax with ax times I cap with this bracket, which term will survive? Only this term, first term, ax bx, and I cap dot I cap is 1. So when I multiply this with this, it will be ax by I cap dot j cap, which is equal to 0. When I multiply this with this, it is ax bz multiplied by I cap dot k cap, and it is also equal to 0. Okay, so only first term survives from here. So it is ax bx. From here, okay, you will have ay by, and from here you will get az bz. Okay, so what is a bar dot b bar? it's equal to ax bx plus ay by plus az bz. So if two vectors are given in component form, then the relation for the dot product is this one. So you got this? Yes, no? Let us see some problems based upon this topic. Okay. So whatever we have discussed, let's see some problems based upon this. A particle moves from point, so this point to this point. Okay, a particle moves from a point minus 2 I cap plus 5 j cap to 4 j cap plus 3 k cap when a force of 4 I cap plus 3 j cap newtons is applied. How much work has been done by the force? So this is very simple. Okay, so work done is equal to what? Dot product of force with displacement. So force is given, F bar is equal to 4 I cap plus 3 j cap, and what is displacement? So this is initial position vector, this is final position vector. So what is displacement? Final position minus the initial position. Okay, so displacement r bar, or let's call it delta r bar, it is equal to r2 bar minus r1 bar, and this is r2 bar, this is r1 bar. Okay, so this is 4j plus 3k minus 2i plus 5j. So what will be result? So there is no x component in this. Okay, so this minus minus becomes plus, so you have 2 I cap, then plus how many j cap? So minus 5 j cap, and here you have 4 j cap. So 4 minus 5, so minus j cap, okay, and plus 3k cap, plus 3k cap. This is your displacement vector. Okay, this is your displacement vector. So what is work done? It is dot product of force and the displacement, which I am representing by delta r bar. Okay, so it's equal to 4 I cap plus 3 j cap. So there is no z component in this. It's dot product with 2 I cap minus j cap plus 3k cap. Okay, so this is equal to x component with x component. So 4 times 2. Okay, 4 times 2 plus y component with y component, multiply y component with y component, 3 times minus 1, and z component with z component. So z component is 0, 0 multiplied by anything is 0, so 0 multiplied by 3. Okay, so you have 4 times 2 is 8, 3 times minus 1 is minus 3, 8 minus 3, 5. So 5 joules is the answer. Simple. So let's see this next question. It is similar. A uniform force, this is uniform force, 3I plus j cap Newton acts on a particle of mass 2 kg. Hence the particle is displaced from this point to this point. Position 2I plus k cap meter to position this position. Okay, the work done by the force on the particle is very simple, right? So force is given, it is 3I plus j, and how much is displacement? So delta r bar is this final position vector 4 I cap plus 3 j cap minus k cap minus the initial position vector, which is 2 I cap plus k cap. So that's 4i minus 2i. So 2i, okay, 3j, so plus 3j, there is no y component here, and minus k cap minus k cap minus 2k cap minus 2k cap. So work done in this process is F bar dot delta r bar, or you can call it S bar. Okay, so it is 3i plus j, its dot product with 2i plus 3j minus 2k. Okay, no need to multiply the z component because there is no z component in force. Okay, so it is 3 times 2 plus 1 times 3, right? 3 times 2 is 6, 6 plus 1 times 3 is 3, so 9 joule is the answer if my calculations are correct. Alright, next question. A body moves a distance of 10 meter along a straight line under the action of 5 Newton force. Okay, if work done is 25 joule, then the angle between force and direction of motion of body is. Okay, so this is simple. Work done is dot product of force and displacement. So it is F into S multiplied by cos of theta. And work done is given, it is 25 joules. Force is 5 Newton. Displacement is 10. Okay, so it is 5 multiplied by 10 multiplied by cos of theta. So 5 times 10 is 50. Okay, take that 50 on left side. So 25 upon 50 is 1 by 2. Cos theta equals to 1 by 2. So what is the angle? 60 degrees. Right. So this is also a simple problem. Okay. Next problem. A body constrained to move in y direction is subjected to this force. The work done by this force in moving the body through a distance of 10 j cap along y direction, y axis. Right, 150 joules. Just y component with y component. Okay, so 150 joules is the answer. Very good. Next question. When a body moves with constant speed along a circle, options are no work is done on it, no acceleration is produced in it, its velocity remains constant, no force acts on it. So which of this is correct? No. See, displacement is okay. See, the reason is force is in this direction. Okay, let's suppose body is at this point. Okay, so what is its velocity? In what direction is the velocity? It's in tangential direction. Okay, so let's suppose it is moving in anti-clockwise sense. This is the force, centripetal force. This is the direction of movement. Okay, this is the velocity. So at each and every point you can see the angle between force and displacement is how much? 90 degrees. Okay, if you consider any small displacement, okay, consider any small displacement or consider any displacement, at each and every point the force and displacement, they are at an angle of 90 degrees. Okay, so work done is equal to what? F into, consider any small displacement S multiplied by cos of 90. Cos 90 is 0. So work done is equal to 0. Okay, so therefore no work is done on that object. Is it clear? How to check if two vectors are perpendicular to each other? If two vectors are orthogonal to each other. How will you check? So if two vectors are perpendicular to each other, okay, let's suppose a bar and b bar are perpendicular to each other, then their dot product is equal to 0. Okay, so a bar dot b bar is 0 if a bar is perpendicular to b bar. Okay, so there have been lot of questions based upon this simple topic. Okay, so this one was one of them, right? Because force and displacement are perpendicular to each other, so work done is equal to 0, right? So let's see some more questions. If a bar and b bar, okay, if vectors a bar equals to this thing and b bar equals to this thing are functions of time, then the value of time at which they are orthogonal to each other is. This is the question. So what do we have to do? When two vectors are perpendicular orthogonal to each other, the dot product is equal to 0. So a bar dot b bar is cos of omega t multiplied by I cap plus sine of omega t multiplied with j cap, its dot product with cos of omega t by 2 into I cap plus sine of omega t by 2 times j cap. Take the dot product. So x component with x component, y component with y component. So this is equal to cos of omega t multiplied by cos of omega t by 2 plus sine of omega t multiplied by sine of omega t by 2. So tell me, where does this expansion come from? What is the formula? Cos of a minus b. Okay, it is cos a cos b plus sine a sine b. Very good. So this is cos of omega t minus omega t by 2. That is cos of omega t by 2. This is cos of omega t by 2 and this is equal to 0. Okay, we want the time when they become perpendicular to each other. So cos of omega t by 2 is equal to 0. That means omega t by 2 is 90 degrees, right? Or you can say all options are given in terms of pi. So you can say omega t upon 2 is pi by 2. So 2 gets cancelled. So option A is the answer, right? Okay, t equals to pi by omega. So this was simple. If a vector 2i cap plus 3j cap plus 8k cap is perpendicular to vector 4j cap minus 4i cap plus alpha k cap, then the value of alpha is, again simple question. Okay, so a bar dot b bar is equal to 2i cap plus 3j cap plus 8k cap, its dot product with 4j cap minus 4i cap. So it is minus 4i cap minus 4i cap plus 4j cap plus alpha k cap. So it is 2 times minus 4, that's minus 8, plus 3 times 4 is 12, plus 8 times alpha, and if they are perpendicular, this is equal to 0. So 12 minus 8 is 4. Okay, so take that 4 on other side. So 8 alpha equals to minus 4, and therefore alpha is equal to minus 1 by 2. Okay, very simple. Option B is the answer, right? Okay, next question. If vector sum of two forces is perpendicular to their vector difference, in that case the forces, if they are equal to each other in magnitude, are not equal to each other in magnitude, cannot be predicted. This is the question. Okay, so let's try to solve this. So vector sum, so let's call first one f1 bar and second one f2 bar. So vector sum f1 bar plus f2 bar is perpendicular to vector difference f1 bar minus f2 bar. So if they are perpendicular, this is equal to, their dot product is equal to what? 0. Okay, so now let's multiply. So it is f1 bar dot f1 bar. So this is f1 square minus, you have f1 bar dot f2 bar plus f2 bar dot f1 bar and minus f2 bar dot f2 bar. This is equal to 0. Okay, so now see, a bar dot b bar is equal to b bar dot a bar. How? Because a bar dot b bar is what? It is a times b, magnitude of a multiplied by magnitude of b multiplied by cos of the angle between them. And what will be b dot a? B bar dot a bar is magnitude of b. Okay, b a multiplied by magnitude of a multiplied by cos of the angle between them. Okay, so this is magnitude, that means it's a number. So a times b is equal to what? B times a. There is no difference. Okay, so a bar dot b bar is equal to b bar dot a bar, and therefore this thing gets cancelled out. So this is minus of f1 bar dot f2 bar plus f2 bar dot f1 bar. Okay, so f1 bar dot f2 bar is equal to f2 bar dot f1 bar, but here you have negative sign, so this thing gets cancelled out. Okay, f1 bar is equal to, you can say, f1x into I cap plus f1y into j cap plus f1z into k cap. So f1x into I cap plus f1y times j cap plus f1z times k cap. So this thing and its dot product with this thing, what will be that? It will be f1x square plus f1y square plus f1z square. Okay, minus here you have f2x square plus f2y square plus f2z square, and this is equal to 0. So what is this thing? It is magnitude of f1 bar square, right? What will be magnitude of f1 bar? It is square root of f1x square plus f1y square plus f1z square. So this is magnitude of f1 bar square, and this is magnitude of f2 bar square. So if square of the magnitudes, so this is magnitude of f1 bar square minus magnitude of f2 bar square, and this is equal to 0. So if this is equal to 0, that means their magnitudes are equal, right? Okay, so which is the answer? Yeah, are equal to each other in magnitude. Very good. So option B is the answer. So is there a question in this? Okay, the position vector of particle is given by r bar equals to a cos omega t into I cap plus a sin omega t into j cap. So this is position vector in uniform circular motion. And in uniform circular motion, the velocity of particle is perpendicular to the position vector, right? Position vector directed along the radius and away from the center. Velocity is directed in tangential direction, right? So we had seen this question in uniform circular motion. Now we can solve this question in another way. So how can we solve this? So this is not, actually this will be a difficult or lengthy way to solve it, but we are just going to solve it. So how do you find velocity? It's derivative of the position vector, dr bar by dt. So take derivative sorry. So take derivative of this. What will be derivative of this? So it is a times omega. Okay, why I'm taking omega out? Because it is omega t. Okay, I'm taking derivative of cos of omega t. It will be omega multiplied by minus sine omega t by the chain rule. So multiplied by I cap plus a times omega multiplied by cos of omega t into j cap. So is this thing clear? This is by chain rule. Okay, and now we want to find out whether r bar and v bar are perpendicular to each other. So we'll take their dot product, r bar dot v bar. So what is their dot product? So a omega multiplied by this thing, its dot product with this. So it is a square omega, okay, multiplied by minus sine omega t into cos omega t, minus sine omega t multiplied by cos of omega t, plus we have a times a square omega multiplied by what? Cos omega t into sine omega t into cos of omega t. And you can see here this is same term, okay, but here you have negative sign, so this thing and this thing gets cancelled, and therefore the result is 0. And that's why, since r bar dot v bar is 0, they are perpendicular to each other. Okay, so so this is how we can check. So next we will see how to find out angle between two vectors. Okay, how to find angle between two vectors. So this is one use of dot product of two vectors. Okay, finding angle between two vectors. So a bar dot b bar can be written as what? It is ax bx times, sorry, plus ay by plus az bz, and it can be also written as a times b times cos of theta, where this is magnitude of a multiplied by magnitude of b multiplied by cos of theta. So this thing is equal to ax bx plus ay by plus az bz. Okay, so cos theta can be written as what? This thing ax bx, sorry, plus ay by plus az bz divided by a times b. And therefore, if I want theta, theta is cos inverse of this thing ax bx plus ay by plus az bz divided by a times b. What is a and b? A is magnitude of a bar, b is magnitude of b bar. Okay, so is this thing clear? Okay, so now two vectors are given in component form. We can find out angle between two vectors. So let's see an example based upon this. So the angle between two vectors, these two vectors will be, okay, so this is simple. So is it 90? Let's check. Let's check. So theta is equal to cos inverse of, okay, a bar dot b bar. So which is 3 times 3 plus 4 times 4 plus 5 times minus 5. 5 times minus 5. Okay, so it will not be 90, I guess, or will it be? So 4 times 4 is 16. Okay, 16 plus 9. Yeah. Okay, this is equal to 0, and cos inverse of 0 is equal to 90 degrees. Right. So actually the question is based upon this thing. So since a bar dot b bar is equal to 0, okay, it is 3 times 3 plus 4 times 4 plus 5 times minus 5, and this is 0, so angle is 90 degree. Right. Okay, so we'll see one more question. Okay, so let's suppose we have vectors a bar is equal to, let's suppose it is 3i plus 6j uh, minus, actually I will have to pick the vectors whose cos of angle we know. Okay, so yeah, we can do that. We can do that. So let's suppose a bar is equal to 3i cap. Okay, and b bar is equal to root 3 let's suppose it is 5 by root 2 I cap plus 5 by root 2 j cap. Right, so a bar is this and b bar is this. Okay, and I want to find out angle between a bar and b bar. So this is simple. Okay, so what will be the angle? So we can write cos of theta is equal to a bar dot b bar divided by a by b. Okay, so this is ax bx plus a by by, because we have two components only. So it is 3 multiplied by 5 upon root 2. Okay, and How much is ay by? It is 0. Divided by, in denominator, how much is magnitude of a? It is 3, right? Magnitude of a is, it is ax square plus ay square. If there is az also, az square, right? So you have only 3 I cap. So magnitude is square root of ax square only. Okay. Or you can say ax square plus ay square. Ay is 0. So this is equal to 3. And how much is magnitude of b? It will be 5. Right. So it is square root of 5 by root 2 square plus 5 by root 2 square. 5 square you can take out. Okay. Root 2 square is 2. So 5 multiplied by 1 by 2 plus 1 by 2. That's 1. Okay. So magnitude is 5. So it is 3 multiplied by 5 in denominator. Okay. So 3 times 5 gets cancelled out. So 3 times 5 and 3 times 5 gets cancelled out. So you have 1 upon root 2. So now tell me, how much is the angle? 45 degrees. Because cos of theta is 1 upon root 2. Angle between A bar and B bar is 45 degrees. Okay. So have you got it? How to find out angle between vectors? Okay. So this is simple, right? Another use of the dot product or the scalar product of vectors is finding out component of one vector in direction of the other vector. Okay, so let's see how that thing is done. So let's suppose this is a bar. This is first vector a bar, and this is another vector. Okay, this is b bar. Or I will draw it with same color. This is b bar. Okay, and now I want to find out the component of a bar along b bar. So how to find component of a vector along other vector, or in any direction we can say. So I can resolve this a bar in two components, right? One along b bar, one perpendicular to b bar. Okay, so the component along b bar would be this much, component perpendicular to b bar would be this much. So if this angle is theta, okay, if I know this angle, then how much would be this component? So we can say b bar is in x direction, so this component is ax, so this is equal to a cos theta, right? And this component will be a sin theta. Okay, so what is component of a bar in direction of b bar? It is a cos theta. Yes, no? And what is theta? Theta is the angle between a bar and b bar, right? So if I know a bar, if I know b bar, okay, I know what is cos of theta. What is cos of theta? It is a bar dot b bar divided by magnitude of a bar multiplied by magnitude of b bar. Okay, and I want component of a bar along b bar, right? So this is cos of theta, and I want component of a bar along b bar. So component of a bar along b bar in direction of b bar is what? is equal to A times cos theta. So now I know an expression for cos of theta. We have studied it. And I know the component of A bar along B bar is A cos theta. So what will be that? It is A times this, okay, this relation for cos of theta. So which is A bar dot B bar divided by AB. So this A, magnitude of A and magnitude of A gets cancelled out. What relation do you get? It is A bar dot B bar divided by B. Okay. And similarly, what will be component of B bar along A bar? Right. A bar dot B bar divided by magnitude of A. Okay. So this is simple, and let us see problems based upon this topic. So given A bar equals to this thing, B bar equals to this thing, the component of vector A bar along vector B bar is, so this is simple. Okay, it is, oh, you calculated, good. So it is A times cos theta, and it is A bar dot B bar divided by magnitude of B. Okay, let's find it out. 2I cap plus 3j cap, its dot product with I cap plus j cap, and divided by magnitude of B, which is square root of bx square plus by square. So bx is 1 square plus 1 square, root 2, right? So 2 times 1, 2, 3 times 1, 3, right? So it is 5 upon root 2. Very good. All right. So option C is the answer. So simple to find out components, right? Okay. So let's try one more problem. So here. So component of projection of A bar on B bar. So this is another name for finding out component. Projection of A bar along B bar. Okay. So projection means what? Component only. Okay. Or you can say this is projection of A bar on B bar. Okay. So if you keep a mirror over here, how much will be length of A bar in that mirror? It is known as the projection of A bar. Okay. On that mirror, or you can say in this direction. So projection of A bar along B bar is what? You can say that if you, let's suppose, you shine some light over here from here. Okay. So this is a stick. Okay, A bar is a stick, and you shine light like this. So what will happen? So suppose this is the floor. So there will be some shadow of this A bar, this stick. And how much would be length of that shadow? It would be this much, right? So it is projection of A bar on B bar. You got this? These are different names. The component, the projection, or there can be a question like this. If, okay, so if you shine light like this, what will be the length of shadow of this vector? Or a stick is kept there. Okay, a stick is kept here. How much would be the length of the shadow of that stick? How much would be the length of shadow? It's equal to the component of this vector. Okay, in this direction. That much would be the length of the shadow of the stick. Got it? Yes, no? So let's move on to, let's see this problem. This is simple. So what will be the projection of A bar on B bar? So projection of A bar on B bar, it is just another name for the component. So it is A cos theta, which is A bar dot B bar divided by B. So tell me, 2I cap plus 3j cap, sorry, I wrote 3I cap. 2I cap plus 3j cap minus k cap, its dot product with minus I bar I cap plus 3j cap plus 4k cap divided by, good. So it is 1 plus 3 square is 9 plus 4 square is 16. Okay, so option B. Let's check 2 times minus 1. Okay, 2 times minus 1 is minus 2 plus 3 times 3 is 9 minus 1 times 4 is minus 4, and in denominator you have 26. So 9 minus 4 minus 2, right? Option B. So 3 upon root 26. Very good. Okay, so option B is the answer, right? So this is how we find out the component of a vector, one vector along another vector or in any direction.